Hello.
Hi,
Welcome to our derivatives, a very brief intro video.
and this is going to be our fourth video of the summer videos. My name is Mr. Lakin.
And I'm Ms. Schwartz. We are your hosts for today.
Welcome.
All right, so something you should be aware of are the different ways that we can talk about a derivative within calculus. So when you hear the word derivative, you should be thinking about the instantaneous rate of change, sometimes abbreviated.
IROC,
Mr. Lakin abbreviates it like that. I'm not really sure that happens, but we're going to go with it.
because you rock.
So kind. The slope of a tangent line, different than the slope of a secant line. Mr. Lakin, what is a tangent line?
A tangent line is a line that's going to touch the curve at exactly 1 point.
Not more than 1 point?
Not more than 1 point.
Exactly 1 point.
Exactly 1 point.
Got it. And then we have this messy limit as h goes to 0 of f of x plus h minus f of x all over h, which is notated with f prime. That's what this little prime symbol here means. We're talking about the limit definition of the derivative. That prime symbol will be super important to us. And then finally we have the derivative English meaning. I want to focus on it's a form of something made or developed from another form. So when you talk about the derivative of one thing versus another, it's following from an original given, which is what we will have. We'll have the function, and then we will take the derivative of it.
Now, one thing we should let them know, Ms. Schwartz, is that this information on this page is actually not going to be on their quiz the first week of school.
Right. This was just
extra info.
Yeah, just stuff for you to have, so we're not just giving you random facts. We want them to have some context with them.
So here's some fast facts, and I don't know if you guys are aware of these, but here they are for you. So for instance, 3 times 4 is equal to 12, and we kind of just memorized that over the years. 5 minus 6 is negative 1, and anything times 0 is 0. Log 10 is 1. Sine of pi over 2 is 1, and Ms. Schwartz wrote a 10 there for the log because it's base 10. Secant of pi over 3 equals 2. I'm not really going to be explaining these, but these are just facts that you know, and we want you to memorize the derivative facts. We have 5 divided by 15 halves is, of course, 2/3.
I mean, everybody knows that fact.
Tau? Is that a tau? By George.
It's a tau.
So tau is equal to, approximately equal to 6.283, which is twice pi.
So should we be celebrating Tau Day?
We should, well, we already celebrated it.
It's true. June 28th, Tau Day.
Vi Hart has a great video on Tau Day, but that is neither here nor there. We should keep going.
That's us getting off on a
tangent.
All right. So again, these facts, not going to be on your quiz that we talked about the first week, but all of these facts are things that you should be aware of and we should be able to recall at any given moment, especially these unit circle things. Yeah.
True.
Okay, so now let's talk about the actual derivatives that we would like for you to know. So the first one we're going to talk about is when we're taking the derivative of a power function. So what makes a power function is when you have a base that is varying. Okay. A base that varies. And a power or an exponent that is a constant. Now, Mr. Lakin, can you give me some examples of constants?
Constants are numbers. So like 3, 8, 0.5, 1/2 could be a constant.
Could they be negative?
They could be negative. Let's do negative 4
4, okay.
and negative 12,182.
Ooh, 12,182. That's a big one, but still a constant.
Still a constant.
So the base is something that is varying. The power is something that is a constant. And so to take the derivative, which is the instantaneous rate of change, the slope of the tangent line, the limit definition, etc., our shortcut for it is we're going to take the constant, we're going to swing that down in front, we're going to multiply it by our base, raised to that same constant having been lowered by 1. So you might be thinking, like, that seems like a cheap little shortcut, and it kind of is. This is how we take the derivative of a power function. Over the course of the course, we will teach you the actual reason why that works and how that comes to be. But for right now, we're just, again, worried about learning those quick, fast facts that we would like for you to have for our first couple weeks of calculus. So using this same concept, if I think about x to the third, I'm going to bring that 3 down in front and drop the power, so we get 3x to the second. This one is going to be 8.5 x to the 7.5. This is going to be 1/2. Mr. Lakin, how do I subtract A 1 from a half.
Okay, so we got to do 1/2 minus 1, which is 1/2 minus 2/2.
How'd you get 2 halves?
That's the same thing as 2 over 2 is 1.
Oh, yeah, it's like it's dressed
common,
up.
Right, common denominator. And then subtract the numerators.
Okay, so negative 1/2
1/2
is what we're looking at. X to the negative 4th. Oh, nope, see?
Nope.
This is where I make
Not
mistakes.
True. Not true.
This is going to be negative 4 x to the negative
5. And
this one just
wow.
because negative 12,182
x to the but we're going to subtract 1, so negative 12,183.
Got it.
Oh.
Okay, so you just kind of bring the number down in front and then drop the power. That seems pretty basic, right?
Seems straightforward.
Okay, so then this one here says that I'm taking the derivative of k, and k is just representing a constant. And so you might be asking yourself, well, Ms. Schwartz, how is this a power function? This is where math is sneaky. I can think about a constant. So let's say I was taking the derivative of the number 6. Hopefully we agree that that is the same thing as 6x to the 0th power.
Mm-hmm.
Does that seem okay?
Mm-hmm.
So now if I apply my power rule, I'm going to move this 0 down in front. I'm going to say 0 times the 6 that's in the way. That's going to be 0. And then, well, it doesn't matter what this is because this is 0 times anything. And we learned...
You'll get x to the negative 1, but it's 0 times...
Times x to the negative... Right, and we learned that 0 times anything is just going to be 0. So now again, let's think about this from a graph perspective. If I'm graphing a constant is just a horizontal line. And we said that derivative means slope. Mr. Lakin, what's the slope of a horizontal line?
0.
0 rise, only run. So our derivative of any constant is going to be 0. So that constant could be the derivative of 6, like we had is 0. The derivative of negative 12,182 is also
0.
Someone's paying attention. The derivative of 3/4 is
0.
Okay, so let's also think about, what if I wanted to take the derivative of 4x? Well, that's just going to use our power rule. This could be x to the 1st. So I'm going to swing that, it's just going to be a 4x to the 0, but what's x to the 0?
4.
Well, x to the 0 is 1. So this is going to be answer of 4. Again, if we think about a quick graph, just to give a little context, 4x has a line like that. And if I want the slope of that line, the slope is 4.
So you're saying that if I see a coefficient that's a constant, I'm not going to make the derivative of that constant 0.
Correct.
Okay.
So for instance, if I had 10x, its derivative would be 10.
Oh, okay.
If I had 12x, the derivative would be
12.
All right.
All right. Now, one thing that wasn't really pointed out, but I'm going to point it out now, is this d dx. This symbol tells you to take the derivative. So... And my handwriting is not as nice as Ms. Schwartz, so I'm sorry for this. And what we're going to do is we're going to take the derivative of e to the x. And the derivative of e to the x is, it's e to the x. How awesome is that? And the derivative of ln x is not ln x, but that's going to be 1 over whatever this part is, which is x. And it's not going to get much more complicated than that for your quiz. We're just going to keep it at that difficulty level.
So, but my question is, like, e to the x, that's like a power function. So why is that?
By the way, yeah, this is an exponential function. An exponential function differs from a power function in that you're going to have a number raised to a variable, or a constant raised to a variable,
as opposed to the variable
as opposed to
const. Okay.
Right. Now, the log function will usually have a log in front.
That's how we clarify that.
That's how we identify that.
Okay, yeah, okay. That makes sense. All right, and then everybody's favorite, trigonometry. So let's talk about these derivatives, that d dx. We're taking the derivative with respect to x. These are the facts that you need to know. Okay, so you can make flashcards for them. You can study them however you need to. The derivative of the sine of x is going to be equal to cosine of x.
Could you guys believe that I wrote that?
The derivative of cosine is going to be equal to negative sine of x. He wrote that one too. The derivative of tangent of x is secant squared x.
And I just want to point out here, for all of these, we're really not interested in you guys knowing where these formulas came from. These are just facts. So just like you saw those other facts before about 3 times 4, Same thing. We just want you to memorize these.
Yes.
And there's a method to our madness that you'll have to accept here. The derivative of cosecant of x is going to be negative cosecant x and cotangent x. Ms. Schwartz is actually writing with her left hand right now. That's why it looks horrible. The derivative of secant x is going to be equal to secant x tangent x. And I'll put parentheses around here to separate this. Ms. Schwartz, you may need to go to your right hand at some point.
This is rough.
And the derivative of cotangent x is going to be negative cosecant squared x. All right.
Okay, so now some things, again, Mr. Lakin mentioned, we just want you to memorize these. Think about it like when you do your math facts, when you say 5 times 10 is
50.
You don't sit there and think I'm counting out 5 piles of 10 things or 10 piles of 5 things. It's just a fact that you know. So similar with this video that we're making, these are just facts we need you to know. We will get into the how, the why, etc. over the entire year. We'll be working on it. That looks much better. That was Mr. Lakin's handwriting. That was beautiful. One thing to note, make sure we put our multiplication in there.
Yep, we are multiplying the functions.
And then make sure we are squaring our results.
Correct.
Something that might help you in memorizing, learning these. Please note the derivatives of all of the cos have a negative sign on them. So there's some other ways that you can find some strategies to memorize those and make sure that they are in your head for the first week of calculus. All right, so
study up, guys. Make sure you hit those books. And then if you're not sure about any of this, you're more than welcome to look it up. Just be careful that when you're looking things up, you don't go too far ahead. Again, all we're really looking for is just the basic facts.
Basic facts.